Well. Shopping for a car?
Yep, Carvana made financing a car as smooth as can be.
Oh, yeah?
I got pre-qualified instantly and had real terms personalized just for me.
Doesn't get much smoother than that.
Well, I got to browse thousands of car options on Carvana, all within my budget.
Doesn't get much smoother than that.
It does. I actually wanted a car that seemed out of my range, but I was able to add a cosigner and found my dream car.
It doesn't get much...
Oh, it gets smoother. It's getting delivered tomorrow.
Visit Carvana.com or download the app to get pre-qualified today.
Good day, everybody, and welcome to Astronomy Daily for Friday, the 21st of July 2023. My name is Tim Gibbs, and I will be your host for this episode.
Astronomy Daily, the podcast, with your host, Tim Gibbs.
Now, as usual, I have Hallie, my AI assistant, in the studio with me. And Hallie, I understand that you've got some interesting stories for us this week. Over to you, Hallie.
Hi, Tim. Yes, I do. Here are my headlines for today. India's Chandrayan-3 spacecraft is continuing its circuitous journey to the moon with a series of burns to raise its orbit around Earth. Chandrayan-3's moon landing attempt is scheduled for August 23rd or August 24th. Chandrayan-3 launched on July 14th into an orbit around Earth and has been slowly boosting its orbit ahead of a final shot toward the moon. The lunar spacecraft's propulsion module completed a fourth orbit-raising maneuver on Thursday, July 20th, the Indian Space Research Organisation ISRO has stated. The engines fired at the spacecraft's closest approach to Earth, raising its apogee, or the farthest point from Earth of its orbit. The next firing is planned for between 2 and 3 p.m. India Standard Time, 0830 to 0930 GMT, 4:30 to 5:30 a.m. Eastern Daylight Time, on July 25th, ISRO added. A translunar injection and TLI burn will take place on July 31st. The maneuvers are part of Chandrayan-3's low-energy approach to the moon that will see it attempt a landing on the moon on August 23rd or August 24th. The mission is India's second attempt to touch down on the moon, following the failed 2019 attempt made by the Chandrayan-2 lander. The new mission has built on the lessons learned from the earlier landing attempt. If touchdown is successful, the mission lander and rover will collect science data on the surface for up to 14 Earth days, a single day on the moon. The spacecraft are not expected to survive the deep cold of the lunar night. Comet Ponds-Brooks suddenly sprang into action overnight, brightening by 5 magnitudes. Now you can see it in a 6-inch telescope. The periodic comet 12P/Ponds-Brooks won't come to perihelion until next April, but it's already out the gate. On July 19.8 UT, the magnitude 16.6 comet had few visitors. One night later, amateur astronomers Elek Tamás, of Harsona Observatory in Hungary, spotted it at magnitude 11.65 magnitudes brighter. Now comet chasers can't wait for darkness to arrive so they can have a look. Fortunately, the sky was clear on the night of July 20th, and the comet near the zenith not far from the head of Draco. I pointed my daub in its direction, carefully star-hopped to the correct location and landed on an 11.4 magnitude star. That's exactly what it looked like at low magnification. Upping the power to 242 times, I suspected a coma 10 to 15 across, but when similar comas appeared around neighboring stars, I attributed it to light scatter and SOSO seeing. Images from the night clearly show a fuzzless, pinpoint object. Comet 12P/Ponds-Brooks is still more than 531 million kilometers, 330 million miles, from Earth, well beyond the orbit of Mars. Given its distance and the freshness of the outburst, a stellar profile is exactly what you'd expect. That's good news for observers. Typically, an 11th or 12th magnitude comet would require at least an 8-inch telescope to see. But since all of its light is concentrated into a point, even a 4-inch or 6-inch scope will show it, at least for now.
The Astronomy Daily Podcast.
Thanks for that, Hallie. Now here's an interesting story for you. Carl Sagan's master for golden record on the Voyager spacecraft has come up for auction. The two reels are not much to look at, and the quality of their audio recordings, while described to be excellent, exists in other formats. Their pedigree, though, is unique, which may be why they are estimated to be worth more than 10 times their weight in gold. An appropriate figure given that they were used in the creation of perhaps the most iconic golden records in existence. On Thursday, July 27th, Sotheby's will offer famed astronomer Carl Sagan and award-winning documentary producer Chandrayan's personal copy of the master recording for NASA's Voyager golden record. Identical discs included as audio-visual time capsules that are now farther away from Earth than any other human-made object in history. The Voyager missions are among the greatest acts of exploration in history. The undertaking of the golden record reflects the incredible optimism, fascination, and humanity when faced with the great unknown of the universe. Led by Chandrayan and Carl Sagan, the production of the record was a monumental task, and it's a great honour to offer their personal copy of this most profound and unique artifact. Cassandra Halden, Sotheby's global head of science and popular culture, said in a statement, Sotheby's estimates that the golden record will commence at around about $400,000 to $600,000. The minimum bid is currently $300,000. They are listed as Lot 80, the final item in the auction house upcoming space exploration sale in New York. The cosmic zoo has strange beasts, and astronomers stumble across in the most fascinating ways. Not long ago, a team in Australia found a highly unusual magnetar, one of the weirder denizens of the starry zoo. It's called GPM J1839-10, and it lies some 15,000 light-years away in the direction of the constellation Scutum. GPM J1839-10 actually showed up in observations beginning several years ago, hiding in plain sight. Astronomers describe it as an enigmatic transient object that would appear and disappear, emitting energy 3 times per hour. It wasn't until 2022 a team from Curtin University observed it with the Murchison Wildfield Array radio telescope in outback Western Australia that identified it as a possible long-period magnetar. This remarkable object challenges our understanding of neutron stars and magnetars, which are some of the most exotic and extreme objects in the universe, said team lead Natasha Hurley-Walker. It's only the second long-period magnetar ever found. Hurley-Walker's undergraduate student Tyrone O'Doherty found the first one. His discovery took everyone by surprise. We were stumped, Hurley-Walker said, so we started searching for similar object to find out if it was an isolated event or just the tip of an iceberg. Astronomers have studied magnetars for years. They're extremely magnetic dead stars that release energy in bursts ranging from seconds to a few minutes in length. They probably originate as massive stars die in supernovae, and with the leftover remnant collapsing to form a neutron star. There's also some evidence that colliding neutron stars could create magnetars as well. The core of a magnetar is a spinning neutron star only about 20 kilometers across. They are likely to have solid surfaces. The core usually has a mass of 1 million tons or more. It has incredibly strong magnetic field, hence the name magnetar. As it spins, the magnetar emits periodic bursts of radio and other emissions. Charting those outbursts is like listening to a ticking clock, but using radio telescopes to capture the signals. Most magnetars lose their magnetic fields after about 10,000 years, which makes them short-lived phenomena in cosmic terms. This new one emits energy bursts for about 5 minutes every 22 minutes. That makes it the longest period magnetar found. It might also be an aging one, about to stop advertising its presence. We'll never know. At least not for the time being anyway.
The Astronomy Daily podcast.
Okay, Hallie, do you have a terrible joke for us this week?
Sure, here's a classic but terrible dad joke for you. Why don't scientists trust atoms? Because they make up everything.
Yes.
Yes, Hallie, your jokes just get worse. Thanks very much, everybody, for listening to today's episodes. Don't forget you can catch Steve on Monday and myself as usual on Friday. And if we also have time, we can do a one story on Wednesday. You can catch all of our episodes at spacenuts.io and at bytes.com. See you next week, folks. Bye for now.
Thanks, Tim, TTFN.
Bye.
The Astronomy Daily Podcast.